So welcome on stage, Frank and Marion.
And Ken.
Of course. Sorry for that.
We saw that the CEO was coming and we said we drag him on stage because it's always more valuable to get the customers.
So that's the kind of agile approach we love, right?
Yes.
Yeah.
Great. So you spent with us some time already today. What is your favorite part in the MindSphere Lounge?
Well, it's amazing. I mean, it's so big, and it's impressive. I mean, I think it's kind of giving the right feeling about what Siemens is about and what MindSphere is about. So,
okay, great. What is the use case about that you will be talking about in a minute?
We will be talking about predicting failures and improving overall equipment effectiveness.
Okay, that's really
with
cool.
the help of digital data and modeling.
So I think prediction is really important in this whole conversation because you have customers in different phases. So there is connectivity, then you have the data extraction, then you need to put the data somewhere. But I think prediction is important because this is how you really extract the value, because you can plan better, you reduce downtimes, efficiency goes up. So I'm very curious to hear from you guys. The stage is yours.
Yeah, thank you.
Thanks.
So just to frame a little bit why we are on stage and why we're here. So Sebastian already mentioned it, but the way we got engaged with Precognize is that we did a 3-month innovation sprint. So we, as out of my role as being responsible for external innovation, I got in touch with Precognize, and I really liked how they approached the preventive monitoring and predictive maintenance in the process engineering industry. And through our engagement, we just said, okay, let's get started. Let's have 3 months and see how far we can get. We highlighted this also in a joint workshop where we just said, okay, let's get developers from your side, developers from our side. Let's get in a room for a week and just see how far we can get and what's coming outside. And at the end, we pitched the solution that we created in, I'd say, 3 days, more or less, to relevant stakeholders. And for me, this was very impressive to see how fast we can share the knowledge and create something meaningful for customers. I don't know, Ken, what did you think?
Yeah, well, I'll give you a little bit about what we felt and what was in it for us and what I think in it for most of the people that are around here. So first of all, we were extremely surprised by how fast Siemens is moving. Siemens that you're seeing here is actually a startup, and I'm coming from a startup. They're fast, responsive, things were streamlined, and this was kind of amazing for us. Now, we see that the digital transformation is a journey, okay? And for those of you who are thinking, what should they do next? It's a journey, it's not a one time. And when you're going through that journey, we felt that for some of our customers, it will make sense to go together with MindSphere as their main infrastructure, where applications like ours can play an important role. And I think that the pace of doing that and proving that it's possible, that everything can run on MindSphere, and then we can onboard a plan, and we can onboard another plan because the data stream is the same, and everything is running fast, was something that we can learn from, okay? And something that we've done it once, and we'll use it over and over and over and duplicate it. So it will make it easier for all of you to use our application, which Frank will show in a second.
Yeah. So maybe just to highlight, it's one part about the partnership and the way that we can grow together. Mm-hmm. It's the trust that we bring to the table, the energy to be there jointly. But on the other hand, it's also the solution that we can create, the value add that both solutions bring to our customers. And I'm sure Frank will tell you a little bit more about the details and what we actually achieved and what solution we can now provide you and the process industries.
Yeah, and I think, again, it's throughout this journey, some of the things we can provide, other things you need to build yourself, but you have the tools to build it on MindSphere. So it's a good place to kind of hook up for your journey, okay? Because it's not a one-time installment of an application. And also what we're also seeing from the market is that many customers don't know what to choose. Doing this infrastructure and having the ability to choose different applications is something that can bring value. And we believe that if it can bring value to our customers, then it's great for us. So it's a win-win situation.
Yeah. Thank you. I think this summarizes it perfectly. So we will or leave some room and space and time for actually showing the solution we created in this short amount of time. So enjoy.
Okay.
Back to you, Frank.
Yeah. Thank you very much. So, ladies and gentlemen, welcome to the next 15 minutes of predictive analytics, predictive monitoring. Okay. The solution I want to present is a combination of SAMGUARD, the predictive solution brand, and Samsung and MindSphere, Siemens MindSphere. Siemens MindSphere and SAMGUARD can help you reap the benefits of connected intelligence. You need, in order to predict and generate overall equipment effectiveness, you need data. We're talking a lot of data, okay? A lot of data, data lakes. And to manage this data is often very difficult. We can, with the help of Siemens, seamlessly capture and transfer this data, analyze it, turn data into insights, and then again, from the insights, generate actions. Siemens calls this events. And the user gets a very advanced, a meaningful analysis tool that he or she can drill down and explore more insights for his operations. And all of this you get in a secure infrastructure in one place. Okay. So the term end-to-end solution is pretty overstretched, but in this respect it's truly an end-to-end solution, and Precognize is proud to be part of an expanding MindSphere portfolio. Now, SAMGUARD is focused and expertise is mostly in the process industry. Okay, our home is the chemical and petrochemical industry, oil and gas, refineries, but also other process industries such as paper, cement, steel, food, and recycling. Now, what do we mean by predictive monitoring? You know, most of you know the term predictive maintenance, but this is a very narrow, small part of predictive monitoring. Imagine the cost savings you generate when you just focus on the maintenance part. It's not significant. It's okay, but this is not the size of the price. While if you look at generating value from additional production, now we're talking big improvements and big gains commercially. Okay, that's why SAMGUARD is focusing on more production. Now, more production you'll get when your overall equipment effectiveness is improving, is increasing. Tenths of a percent. Now, the OEE is defined by first availability, technical availability, multiplied by the performance of your asset and the quality you get as an output. Only if you look at all three aspects, you really improve your operation. So we do monitor all the signals from all the sensors of your asset. Could be thousands of them. Okay, only the ones that generate or give you an indication about problems in your plant, those will be extracted and followed up on, and that allows us to create an early detection. What can we detect? Of course, equipment failures. That's expected. This is the baseline. Everybody needs to deliver that. However, also we can check deviating processes and alert the operator if processes drift from the normal behavior. The same goes for suspicious operation. Imagine an operator does something that he's not supposed to do. Yeah, you want to catch that early and not wait for 2 or 3 shifts. And eventually, or finally, we can include data from quality labs through our soft sensor ability and also help improve the quality, the golden quality. Now, all of this is possible only if you look at your asset as a whole. looking at just specific individual pieces of equipment will not get you these insights. Okay, that's why we say we monitor any type of equipment, we'll detect any type of problem because everything is connected. It's a many-to-many relationship. Yeah? Now, where do we start? First of all, the data is generated by the sensors in your equipment. That is channeled to the process system, usually DCS, and from there you save it. Yeah? Save it in an historian, and now you save it in your MindSphere data pool. And from here, from the MindSphere data lake, we'll take the data and analyze it. What data are we talking about? It's not only just equipment data, like vibration, bearing, temperature, current, and so on. No, we also can digest process data, like level, flow, pressure, or anything like this. And you don't have to add any additional sensors, you don't have to add additional hardware. We start from what you've got already. Okay. From here, we go into the analytical part. The big data is turned into smart data. And of course, the operators have to have a user-friendly interface where they can identify the problems and then start follow up on, take the right course of action. And all of a sudden, they have options what to do. They don't have to act immediately necessarily. Okay? So the implementation is pretty swift. After an initial homework of determining a couple information and setting KPIs, there will be 1 to 2 weeks of intense workshop type of atmosphere implementation. And after these 2 weeks, you get results. Okay? The initial step is to do an impact analysis. Very important to understand your deliverables, what you want to achieve, the KPIs you want to measure it against. Therefore, we need to load your historical data and do an initial analysis, let machine learning run through this, and create a small model where we can create the evidence. Yeah? We call it like a foster child. That's a proof of concept, basically. Very small. Then the real online pilot begins. We connect to your online data, because from now on, in a minute interval, we digest fresh data. The model will be expanded to more and more parts of the assets. And you get, of course, an on-site training and monitor every morning the results that you get from the system. Now, why should you believe me? So let me give you a little glimpse and excursus into the technology. Okay. First of all, we use machine learning to understand the quality of the historical data and determine through an unsupervised process states or clusters of normality. Because as you know, in the process industries, you don't have many failures. You do not have failures maybe in years in a valve, in a pump, in a reactor. So there is nothing to help you predict linear. So that's why we determine the normality, first of all, of every tag. And we're talking thousands of tags. Everything that your big plant has. Then we create the clusters of normality. And as you also know, there is not just one normality cluster. There are several. You could have seasonal effects. Maybe you have a batch production. You have a startup phase production and then shutdown phase. All of these various operating modi can have their own normality pattern. And that's being detected. So imagine dozens of normality clusters. And this is giving you the baseline model. This is the first pillar. No, just the first pillar. The second pillar is the digital model. Yeah, this is necessary to get the quality in prediction and avoid false alarms. We don't want to spam your operators with false alarms. Okay. So first we take the data headers, just import them. Your people, or if you have available the digital structure, we import the digital structure and create this skeleton of your asset. What no company, no customer has to date is the plant behavior, the processes that happen in between the pieces of equipment. Okay, this is usually in the brains and the heads of the domain experts, and that's why they are part of the solution. Okay, once the model is done, after about 2 weeks, the human eye sees a nice fishbone diagram with everything to everything connected. However, the machine sees your asset as a cloud, point cloud. And the software basically turns your plant into a mathematical graph that includes the relationship between equipment and processes and everything. Now imagine where the circle is, data shows you there's a problem in the making. The operator looking at the dashboard can see the relationship and with his knowledge identify the real root cause and take the appropriate action to mitigate this issue. And here both pillars come together, the data pillar and the digital model, with the graph analysis engine. You have the historical data in the belly, it's analyzed. Now every minute you get fresh information, fresh data. And those data points are projected against the digital model. Right now you don't know which of the fires is actually a statistical anomaly, just a false positive, or a true issue in the plant. And the model does the following. The graph analysis aggregates these anomalies into a problem, if there is one. And false positives get ignored. That's why how your operators just get a few alerts a day, even if you were talking a big plant. And after the insight, you can take the appropriate action, create an event in MindSphere, and the issue gets solved. Now, this is the user interface. The inner circle that you see is gray. That's 100% of your plant. The next outer circle, there are the major segments of your plant, and the segmentation goes into smaller details until you cannot divide the asset anymore. And the red dots is where you have an issue. So you can either click on one of these tiles, or you go into the top navigation and click on to-dos. This is basically taking the data from MindSphere, analyzing it, creating insights and indicated actions derived from that you can then follow up on. Of course, we have typical use cases when this is not monitored. When the system creates insights that are not monitored, the first case can happen 2 weeks in advance. The issue was raised, and next day another alarm. The alarm was ignored. 2 weeks later, a fan motor burned and brought the plant down. That's a half-a-day shutdown and very costly. Okay. Next example from a chemical industry. A valve was about to fail. The early indication was enough to alert the operators. They replaced the valve and avoided a major shutdown that would have lasted at least 1 day. So depending on your industry, we're talking tens or hundreds of thousands of dollars or euros, up to millions of euros per day. And it's not just the commercial side. Think about the HSE issues. Yeah? When a flaring event goes off and something spills and the negative PR in your neighborhood, yeah? These type of events make the media within few minutes. And also you can avoid these events. Now, summarizing, SAMGUARD Precognize is not just covering individual small pieces of equipment. It's not condition monitoring in the narrow sense. We are covering the entire plant. Okay. Second, we found a way to avoid the alert fatigue. You all know this, your operators get spammed sometimes by false alarms and they cannot follow up. So what is human nature? They get ignored. But by ignoring the alarms, you run the risk by missing the big one. And that's also an issue. The implementation is rather fast. after some homework and preparation work. It's a 1 to 2 week intense workshop type of atmosphere, very energetic. Your operators are part of the solution. They give the input, and there's no need for a data scientist. But what you need is a domain expert, somebody who knows this particular asset in and out in order to create the connection between the equipment and the processes. Okay. So concluding, both Siemens MindSphere and Precognize address the same industry. MindSphere is a multiplier of digital solutions and new business. That's why you guys are here. And Precognize offers owners, operators, reduced downtime, increased availability, and improved quality. Thank you very much. If you got any questions, we are here to answer them. Happy to get any questions. Thank you very much. And thanks to MindSphere.
Siemens, ingenuity for life.